Alright guys, here are going to be your similar polygon notes. This is 4a.2 notes. We first need to make sure that we understand the difference between similar and congruent. Congruent is same size, same shape, which we covered at the very end of the first semester. Similar is going to be the same shape, but now we have a different size. So we open up the first flap. We're going to change a few things in here. Okay. The first thing that I'm going to have you guys change is we're not going to talk about a common ratio. So let's go ahead and cross that off. Instead, we are going to define what a scale factor is. Scale factor is represented by a lowercase k. So if you ever see that lowercase k, you know what that means. This is going to be a multiplier. It's a multiplier that tells you how much bigger or smaller a figure will get. Multiplier that tells you how much bigger or smaller a figure will get. Now, we will talk more about that in a little bit. First, number 1 and 2 is going to be a review and kind of an extension of the 4a.1 Part A notes when we talked about ratios. Ratios are a comparison of two or more quantities. And on the 4a.1 Part A notes, the foldable, we only compared two different ratios, and we learned we had to work backwards. These are simplified numbers, and to simplify, we divide them by the same exact number. So we need to work backwards to figure out what the original numbers were by multiplying by the same number. This number is an unknown number, so we're going to use the letter x. Here, the lengths of the sides of a triangle are in the ratio 3 to 5 to 7. Its perimeter is 45 centimeters. We want to find the length of the longest side. The first thing I'm going to do here is I'm going to highlight perimeter is 45. Okay? This tells me what I'm going to be setting it equal to. The next thing I'm going to highlight in a different color is what I'm asked to find, what I'm looking for, and that's going to be the longest side. And as discussed, when we have the 3, the 5, and the 7 here, the longest side is simply represented by the largest number. So we're going to be looking at that 7 right there. Okay? So let's look at how to set this up. Again, these are simplified, all three, the 3, the 5, and the 7. We got those by dividing all three by the exact same number to simplify. So we need to do the opposite and multiply by the same number our unknown, which we will represent with a variable, and we will set them equal to, we'll add them together to equal our 45, because you will add the three sides to equal our perimeter. So we will take our 3x plus our 5x plus our 7x and set it equal to 45. Some of you may prefer just to go ahead and add these three numbers, 7 plus 5 plus 3 to get 15, and just throw down a 15x. We will set this equal to the 45, or you can just come over here and combine these together, combine like terms. Divide both sides by 15. We find out that x is going to equal 3. This is what we divided all three of the side lengths by to get the reduced simplified ratio that we see here in this problem. So we did want to find the longest side. So our longest side, as we said earlier, was going to be that 7x. So that's the one we're going to be looking at here. Okay? All the shadows, I'm just opening up all my markers, getting them ready. So we're going to take that 7, we're going to do as a substitution property, substitute in 3, and we find out that our largest side is 21 centimeters. Okay. Number 2 is another very, very common one. Hint, hint, know how to do this one. We have the measure of the angles in a triangle are in ratios 1 to 2 to 3. Find the measure of the smallest angle. So first, I want to highlight back in what I highlighted perimeter with. What helps me determine what I will set this equal to, and it's going to be that word triangle. The reason I'm doing that is because that triangle, we remember that we're talking about angles. A triangle's angles are going to add up to 180 degrees. That's our triangle sum theorem. Okay? They want us to find the measure of the smallest angle. Okay, and the smallest angle is going to be the smallest number, which is that 1, which we got really lucky because that's just going to be represented by an x. So once we solve for x, we already have our smallest angle. Okay, again, we're going to take each one of these and add an x to it. Now I don't put a 1 in front of my x, so there's the 1x plus the 2x that's next plus this 3x. And we set this all equal to 180 for 180 degrees. Again, some of you may have just added the 1 plus 2 plus 3 and just thrown down a 6x. That's fine. And then we divide both sides, and we find out that x and also the smallest angle is going to be equal to 30 degrees. Okay? And the reason, again, that we're not substituting like this one is because the smallest angle was just an x. Okay? This one right here. So now let's review scale factor. A few things we need to remember about a scale factor. When we're going from one figure to another, we can either get bigger or smaller, as we discussed in that definition. If we are getting bigger, we call this an enlargement. And when we have an enlargement, in fact, what I'm going to do is I'm going to take this and kind of draw a line. Well, thought it would look a little better than it does, so I can separate the two sections here. So we see now that we're going to a different section. An enlargement means that our scale factor, I'm going to use that little lowercase k, if a figure is getting bigger, the scale factor needs to be bigger than 1. So this says the scale factor is greater than 1. If we're getting smaller, we're going to have a reduction. And in a reduction, our figure is getting smaller, therefore our scale factor needs to be smaller or less than 1. So you always want to ask yourself at the very beginning and the very end, is my figure getting bigger or smaller? So should my scale factor be bigger or smaller than 1? Technically, in a reduction, the scale factor should be greater than 0 and less than 1. That's just stating that it cannot be negative. You can never have a negative scale factor. Now, here we want to know what is the scale factor of quadrilateral ABC to quadrilateral EFGH. And I have been teaching this all day, so sorry if I fumble with the letters. Now, one thing we need to pay attention to is just the way that it's drawn is not necessarily where we're going. Sometimes they will want to go from the right to the left. They'll say, what's the scale factor of EFGH to ABCD? So you have to pay attention to the words, not necessarily the picture. Here it is going from ABCD to EFGH. Okay, so we need to talk about our scale factors formula. Our scale factor formula is new over old. And remember this, because if we paint the walls, we put a new coat of paint over the old coat of paint. We lay bricks down, rows of bricks. We're going to put a new layer of bricks on top of or above the old layer of bricks. So another thing we need to do is figure out which one is new and which one is old. Unlike the ratios, we now switch. Okay, the new is going to be the second one listed. So that would be the EFGH. We're going from ABCD to EFGH. So this is going to end up being our new one. This will be our olds. So we ask ourselves, okay, are we getting bigger or smaller going from ABCD to EFGH? We are getting smaller, therefore we are going to have a reduction. So when we find our scale factor, we should find out that it is going to be less than 1. This is probably going to smear my ink. Okay. So that's a way to check also. Now when we do our new over old, all you need to do is find one pair of corresponding sides. And it doesn't matter which ones you choose, okay? In this case, I'm just going to go ahead and grab the first two letters in the names. I have AB, which will be this 10, and EF, which will be the 5. Remembering that new goes on top, old goes on bottom. we get our 5 over 10, which then simplifies to 1/2. And this is a multiplier, so if you take each one of these sides and multiply it by 1/2, you'll get the other side. Half of 10 is 5, half of 8 is 4, half of 6 is 3, half of 5 is not 25. You can barely see it, but this is actually a 2.5. So I'm going to rewrite it so I can see it better. Now we want to find B says we want to find the ratio of the perimeters of both of these quadrilaterals. So I'm going to kind of stick with the EFGH. We could do this either in fraction form or we can do it with the colon because it's a ratio, it doesn't matter. But here what I'm going to do is I'm going to find P perimeter of EFGH, knowing that this is adding all 4 sides together. So I'll have my 5 plus 4 plus 3 plus 2.5, and I will wind up with 14.5 total. P for perimeter of A, B, C, D. I will take my 10 plus my 8 plus my 6 plus my 5, and I will come up with 29. If we do it in fraction form, this can simplify down to 1/2. If we do it in our colon form, it will still simplify down to 1 to 2. Okay, so either one of these will be accepted. With your ratios, because we are used to putting the first one first and the second one second, if you switched it to 2 over 1, simplifying to 2, or over here you did 2 to 1, we will accept that as well. Okay? Then we're going to go through the next section very quickly. The next section is straight review. Up here we are going to talk about our corresponding angles and similar figures are going to be congruent. Same thing as congruent figures. Okay? So here we are going to take a look at, let's find another color pen. There we go. All right. Here this should say measure of angle A. We know that angle A is going to correspond with angle D because of the position in the name. So angle A and angle D correspond. Measurement of angle A is 82 degrees. Measurement of angle E right here. E is the second letter in the name, so it will correspond with B, giving us 38 degrees. And then the measurements of angle F will correspond with our last remaining of angle C, but we don't have it. Easy peasy, go find the missing angle, triangle sum theorem. Take your 38 plus your 82, we will get 120. We subtract that from the 180 to find out what's left over, and we find out this is 60 degrees. Okay. 2 and 3 are going to be the exact same way, except now we have the algebra. Again, this is straight review from the last unit of the first semester. First, let's find number 2. Let's find x. X is associated right here with angle E. And let me change the colors up, and the purple's kind of hard to see. We need to be very careful on this because I know one of my classes, everybody kept telling me, oh, it corresponds with T. T's got a Y. We can't set those equal to each other. So you need to make sure you're always looking at your names. E, the second letter, corresponds with R. Okay, so E and R will correspond. They are congruent. Congruent, we set them equal to each other. So we have x plus 34 is equal to 97. It's kind of hard to see, but it is a 97, not a 47. We subtract that 34 from both sides. We find out that x is going to equal 63. Okay. Solving for y, we see y is over here with angle T. T is the first letter that will correspond with F. So we will set 3y minus 13 equal to 98. We add our 13 to both sides. We're going to get 3y equals 111. Then we divide out. Y will equal 37. Let's take a look at number 3. X is associated with angle K. K will correspond and be congruent to angle Y right here. So we will have 4x plus 3 is equal to 71. Subtract the 3 from both sides. 4x will equal 68. And then divide. And get 17. The next one's very, very nice and easy. Y is associated with angle J. J corresponds, therefore is congruent to angle W, which is 45. So all it is Y equals 45. Nice and easy. Next, let's look at corresponding sides. This is the new part. Okay. Corresponding sides, when you get bigger and smaller, are obviously not going to be congruent because they're getting bigger or smaller. So that we're going to say that they are proportional. This is why we have to know how to set up proportions and solve. Okay. On this one, they're going to want us to find x and y, but there's really not a lot of room to set it up and solve, and I'm afraid it's going to look messy. So we'll just go ahead and cancel this out. We'll just focus on the scale factor because the rest, number 2, 3, and 4, will deal with exactly what that's asking for. Okay? Scale factor, we need to remember, is new over old. And the new one's going to be the last one right here. Okay, they put A, B, C, D, E backwards. So this is going to be the new one. This will be our old one. And we only have one choice here because up here we don't have anything. Here we have an X. Here we have Y. Here we have nothing. So we have to choose side ST. Side ST right here is going to correspond with BC right here. New over old, and then simplify to 2/9. Number 2 is saying that triangle ABC and DEF are congruent. Are similar. There's a similar side. And they give us some information. We want to find the perimeter of the triangle DEF. So the first thing we need to do is we need to draw triangle ABC and triangle DEF and label what they gave us. Okay? AB is 5, BC is 6, AC is 7. On triangle DEF, they only gave us 1, and it would tell us that DE is 3. So we need to find EF and DF before we can find the perimeter. So I like to label this as, let me see if I've got, yep, I got enough colors here. We'll put this as X and as Y, and we'll solve. So we have to do 2 different proportions here. Now, our first proportion, what I'm going to show you guys is a little legend or a key. You'll see it later on in other notes of mine. I'm going to keep triangle. There's several different ways to set this up. You can go between shapes. You can go within shapes. I'm going between shapes, meaning my ratio is going to be, the top's going to be one shape, the bottom's going to be the other. So I'm going to put triangle ABC on top, and I'm going to put triangle DEF on bottom. So I'm going to do my proportional setup here. My fraction bar equals fraction bar. Now I only have one option for the first ratio because I only have one pair of sides, corresponding sides that both have a number. That's going to be here AB and DE. So I'm going to use that 5 and that 3. Now, the new over old does not pertain to this at all. New over old is only when I ask you for scale factor. So it doesn't matter which one we put on top or bottom here. Triangle ABC was the 5, so I'm going to put the 5 on top. Triangle DEF was the 3. Okay. Next, I need to solve for x. So x here is on triangle DEF, and as we see in the legend here, DEF is going to stay on bottom. So we'll put the x over here. We find the corresponding side, EF corresponds with BC, so the 6 will go on top. This is now where we will cross multiply and solve for x. So we're going to get 5x is equal to 18. We divide both sides by 5. X is going to come out to 3.6. Okay? So this side over here comes out to 3.6, which is going to help us when we find our perimeter. When I solve for y, you have a couple options now. Now that you know this side over here, you can use the 6 over 3.6 instead of 5 over 3 if you want. I'm going to stick with the 5 over 3 though. I'm not going to draw another legend or key because I'm going to use the same thing as over here. So I have my 5 over 3, triangle ABC over triangle DEF. And now I'm going to solve for y. Y again is triangle DEF. It needs to go on bottom. And the side that corresponds is AC, so the 7 will go on top. We do our cross multiplying. I get 5y is equal to 7 times 3 is 21. When I divide both sides by 5, y is going to come out to 4.2. Okay. So now to find the perimeter, all I do, if I want perimeter of triangle DEF, we just add that 3 plus the 3.6 that we found plus the 4.2 that we found, and we find out that our perimeter comes out to 10.8 inches. All right. The next section, you're going to see a lot of color coordinating here. Okay. The first thing that I'm going to show you is what I'm going to do about setting up. It's kind of like this key or this legend. You don't always have to write it down. I suggest doing it in the notes. With our proportional setup, I'm actually going to set up the ratio of the sides with the actual letters. Okay. Here I'm going to go between shapes again. I'm going to start off here with MN. I can see right here MN is going to correspond with RS. So our RS is going to be, hold on 1 second, over here with RS. So in my legend or key, I could put MN over RS. And I can take a look at the other side that I'm going to need is this ON. And ON is going to correspond with TS right here. So I could put ON over TS. This just helps me realize where I need, which ones are going to go together. So now whenever I set up my proportion, I take MN, which is right here, of my 3x minus 1, and I'm going to put this over RS, which RS we found out was 4. We will set this equal to ON, which was 8x minus 1, over TS up here of 12. And now I can go through and do my cross multiplying, realizing I'm going to have to do some distribution. If I cross multiply this first, my little lonesome 12 over here is going to remain little lonesome outside the parentheses with my 3x minus 1 on the inside. My students have seen me mention that if it really helps you, you need to make sure one of the biggest mistakes with distribution is we don't see that negative 1. So I like to highlight that so that it stands out. Then when I do my distribution, I'm going to take that 12 times 3x, and I will get 36x. Take the 12 times the negative 1 and get a minus 12. I didn't even do the other side yet, did I? When we cross multiply over here, 4 on the outside, 8x minus 1 on the inside. Distribution, 4 times 8 is going to give me 32x. 4 times that negative 1 is a minus 1. Then we go through and we solve for our x. So I'm going to subtract 32x from both sides. And I wind up with 4x minus 12 is equal to a negative 1. And then whenever I add the 12 to both sides, see if I may have messed this one up here. Hold on. Oh, yep, there it is. That should be a minus 4. So negative 4. There we go. When I add that 12, these cancel. I'm going to kind of shift it over here. I'm going to get my 4x, that's over here, is equal to a negative 4 plus a 12 gives me 8. Divide out, x will equal 2. Okay? Sorry about that little mess up there. Guess I've been teaching all day. Now I'm going to take a look at number 4. It's going to be the same process. We're just using a y instead. Okay? I'm going to use my colors again. I'm not going to do this time. Okay? I am going to do my colors though. Here I see that AB is going to correspond with JK. And I see that CD right here is going to correspond with LM. Okay. So when I set up my proportion, I will take my y plus 1 over the 8, set that equal to the 3y plus 1 over 20. We continue on with our cross multiplication here, keeping the 20 on the outside, the y plus 1 on the inside. We will set that equal to the other cross multiplication. 8 on the outside by himself, 3y plus 1 on the inside. Then with our distribution, 20 times y is 20y. 20 times a positive 1 gives us plus 20. On the other side, we have 8 times 3y, giving us 24y. And then our 8 times a positive 1, giving us plus 8. Now we just have our regular variables and constants on both sides, solving for x. So I'm going to move my 20y since it's smaller. So I'm going to subtract 20y from both sides, giving me 20 equals 4y plus 8. Subtract that 8 from both sides. We get 4y on the right, and we get 12 on the left. Divide by 4, y will equal 3. And there you go.